Okay, let's go. So the dates there for the quiz and the test obviously would get delayed if we miss a day. But we have plenty of time. I had factored in one extra day, so this is not a big deal. So today we do the add and subtract, right? Adding and subtracting is harder because you need a common denominator. Right? These are the basics. We're going to do it in two parts, right? First, how do you add and subtract rational expressions if they already have the same denominator? Right? Something like A over C plus B over C. If you already have the same denominator, how do you add fractions? You just add the numerators, right? A plus B over C. And then you always simplify, like we learned in the last lesson, because sometimes there's going to be some canceling that goes on. Okay. So, for example, in the first one, both denominators are 4x, so I can just add the numerators, 10 over 4x. Okay. Now, can that be simplified? What's the common factor, numerator and denominator? 2. So divide a 2 out, 5 over 2x. All right. Second one, 2x minus 5 divided by x plus 6. Can we simplify? No, you can't simplify, right? Those x's are not factors of the whole numerator and denominator, right? They just occur in one term, so don't take the temptation and try to cancel the x's. Okay. So this is too easy. So try that one. So 7 minus 5. And can we simplify? 1 over 6x. Right? Piece of cake. Too easy. Okay, try that one. Okay, so we already have the same denominator. 2x squared plus 2 over x squared plus 1. So are we done? What else can we do? How about factor out of 2, right? Out of the numerator. Then that'll leave you x squared plus 1 in parentheses, which is the same thing as the denominator. So you can cancel it. So the whole thing is 2. Okay. So how do you add or subtract rational expressions if they don't have the same denominator? Right? So the first step is you're going to rewrite them so that they do. And then you'll do what we did on the previous slides. So in the next slide, I'll say, okay, then how do we do that? Because at this point, you don't know that. All right, so here's the steps for finding the common denominator. And again, we use the term least common denominator, LCD, right? Which is, I'm sure you've heard that before. So first, you're going to factor the denominators, just the denominators, of all the fractions involved. And it could be more than 2. You could have more than 2 things together, or 3, you know, I mean, it could be any number, but most of the time it's 2. So factor the denominators. Then you're going to make a least common denominator. the least common denominator has to have every factor you see in those denominators that you just factored. Right? And if it occurs, for example, if one of them has x plus 1 in it and the other one has x plus 1 in it, it's just in there one time. But if one has x plus 1 in it one time and the other one is x plus 1 squared, then in the least common denominator it needs to be x plus 1 squared. Right? It has to be in there the most times it occurs in any one particular fraction. That's how many times the factor goes there. Right. Once you've determined your least common denominator, then you're going to multiply so that you have the same least common denominator in both fractions, and then you add straight across. Add or subtract. Okay, so here we go. Everybody's done? So, factor each denominator. So, in truth, I mean, most of the times when we talk about factoring, we're just talking about factoring variable expressions. The 9, you know, in a way you don't really need to factor that, but just to show what we're doing here, I'm going to show it like this. 7 over... That was a bad over. 7 over 3 squared x squared. Right? Plus x over, and now this denominator will be 3x times x plus 1. Right, that's that first step. Factor all the denominators. Right. Second step, make an LCD. Right. The LCD is going to have every factor you see in either denominator the most times that you see it. So you would look at it and say, okay, in the first fraction, I've got a 3, and I've got an x. In the second fraction, I've got the 3 and the x, and I've got an x plus 1. Okay, but in the first fraction, the 3 is actually there twice. It's squared, so it should be twice here. And the x is squared, so that needs to be twice here. Right, so you factor and you include every factor you see the most times that you see it. Okay, next, multiply each one of these fractions appropriately so that it has that least common denominator. Now, you see how I left myself so much space there to the right of the first one? Because I know I'm going to be filling some things in here. That's what I would recommend. You know, leave yourself some space. What is this first fraction missing that the common denominator has? X plus 1. So I need to multiply this fraction by x plus 1 over x plus 1. Okay, what's this fraction missing that the common denominator has? It's missing a 3 and it's missing an x. So I'm going to multiply that times 3x, and then that'll make that 3 squared x squared. Okay, now they have the same denominator, so we can add the numerators. So let me do it like this. The denominator is, I don't want that to be red, blue. The denominator will be 9x squared times x plus 1. The numerator will be 7x plus 7 plus 3x squared. So I did a little bit of simplifying as I did that. Okay, now I should, if I'm going to leave the numerator like in not a factored form, it should be in standard form. So let me just rewrite it like 3x squared plus 7x plus 7 all over 9x squared times x plus 1. Now, are we done? Well, it depends. If that numerator is factorable, then you might want to make sure if it has a factor of x plus 1 in it, that might be something you can cancel. Is it factorable? Again, how do you reason that out? You go 3 times 7 is 21. Are there factors of 21 that add up to 7? No. So you're done. There's no more simplifying to do here. And usually when you do these, that's the way you leave the answer. Denominator is probably still in factored form. The numerator may just be in a standard form. Is everybody caught up on that? Okay. Okay. Let's do this one. Now there's one simplification you could make to this one, like before you even start. You don't have to, but does anybody see what you could do that would maybe be wise? I mean, because you have this subtract in front, and then both of these are negative, actually you could just make that a plus, and then that'll make that a plus, and that'll make that go away. I mean, it's better not to have to deal with so many negatives in there. Negatives are always a source of mistakes. Okay, so first step, factor the denominators. X plus 2. Blue. X plus 2 over 2 times x minus 1. Again, I'm leaving myself space because I know I'm going to end up multiplying in there. 2x plus 1 divided by, okay, factors of 3 that add up to negative 4, x minus 3, x minus 1. Okay, LCD. Right, we got to include every factor in either denominator. So the first denominator has 2 times x minus 1. All right, the second denominator has an x minus 3. Okay, it has an x minus 1. Does that mean that I make this an x minus 1 squared? No. Right, if it's there once and it's there once, then it's in the LCD once. Okay. Okay, now what is the first fraction missing from the common denominator? X minus 3. So let's multiply. X minus 3, x minus 3. Okay, what's the second fraction missing from the common denominator? Looks like it's missing a 2. Okay, so we multiplied appropriately. Now we've got the same denominator, which means now we can simplify the numerators and then add straight across. So this is going to be x squared minus x minus 6 plus 4x plus 2 over 2 times x minus 1 times x minus 3. Okay, now we can combine some like terms in the numerator. Looks like that'll be x squared negative x plus 4x plus 3x. Negative 6 plus 2 minus 4 over 2 times x minus 1 times x minus 3. Okay, are we done? Is the numerator factorable? Factors of negative 4 that add up to 3? You bet, right? What are those factors going to be? X plus 4, x minus 1. Okay, well, x minus 1 is in the denominator, so that's going to help us to simplify. If it didn't, then there's no point factoring it. You know, if it was going to give us, you know, x minus 4 times x plus 1, then you can't simplify anyways. You could just leave it like it is. But in this case, we can. Right? This is going to be x plus 4, x minus 1, 2 times x minus 1, x minus 3. Right? And now we can cancel. Looks like we've got x minus 1's in common. So we've got x plus 4 over 2 times x minus 3. Okay. Good to go? Okay. So here's a you try, I'm sure. You try. Okay, so first step, factor. Leave some space. LCD. It's got to have x minus 4, x plus 3, and 12. Okay, multiply. Looks like this one is missing 12. This one is missing x plus 3. Okay, now we can simplify the numerators. This will be 12x plus 12x plus 5x plus 15 over the common denominator of 12 x minus 4. And the numerator could be simplified. That's 12x plus 5x, 17x. Okay. Let's see what we can do next. So try that one. So, factor. Okay, oops. The LCD is, yeah, it's got to have x plus 2 squared because it's squared in this fraction, and it has x minus 2. And then what is this one missing from the common denominator? The minus 2, right? So x minus 2 over x minus 2. What's this one missing? Yeah, it needs that second x plus 2 factor. So I'm just going to write it like that. Okay, now simplify blue. This will be x squared minus x minus 2. This one, that negative is going to distribute right onto both of those. So that becomes minus 6x minus 12. Okay, combine like terms. X squared, negative x minus 6x minus 7x. Negative 2 minus 12 minus 14. Okay, can we simplify any more? Is the numerator factorable by any chance? Factors of negative 14 that add up to negative 7? No, it's not. So you're done. Nothing more. Okay, so that's the adding and subtracting of fractions when they don't already have the same common denominator. Okay, then the last part of this is complex fractions. And by complex fractions, we mean fractions that have fractions inside the numerator and denominator. That's complex. And you simplify it by turning it into just a fraction. Get rid of those inner fractions so that it's just a simple rational expression. Okay, so that's an example of a complex fraction, because there's fractions in the numerator, fractions in the denominator. So the first way that we can simplify that is, if you look at the denominator has two terms. So this is kind of like what we've been studying in this lesson. Let's just find a common denominator for those two terms and add them up. Then we'll have one fraction divided by another fraction, and that's what we went over in the homework last night. How do you divide a fraction by a fraction? You flip and multiply. Right? So that's this process. So what would be the common denominator between for both of these fractions in the denominator here? Yeah, LCD, I'm going to put it right underneath. LCD for the denominator only, although it would be the same, right, is x times x plus 4. Okay, so if I was going to simplify this, I would say, what is this, the first fraction missing from the common denominator? It doesn't have an x, so let me do this, x over x. And what's the second fraction missing from the common denominator? X plus 4. Okay, now we can add these up. Okay, the numerator of this big fraction is unchanged. 5 over x plus 4. And we're going to have to add x plus 2x plus 8. Divided by x times x plus 4. And that could be simplified. 5 over x plus 4 over x, 3x plus 8. And that's over x times x plus 4. Okay. Now we've got one fraction divided by another fraction. So how do we do that? We flip and multiply. So 5 over x plus 4 times x plus 4 over 3x plus 8. Okay, cancel. So it looks like we've got an x plus 4 here and here. Does that look right? I guess so. So this is 5x divided by 3x plus 8. Okay, so that's one way to do it. The good thing about this method is it's really just incorporating things you've done before, right? We've already learned how to add fractions, and we've already learned how to divide fractions. So you're not doing anything new. And the next one you might consider to be a little bit something new. And that is, instead of doing what we just did there, we're going to find the LCD for all the fractions, all the inner fractions. And then we're going to multiply the numerator and denominator by that LCD, the numerator and denominator of the big fraction. All right, so what would be the LCD for the whole thing here? LCD, right? X times x plus 4, just like that, right? So what we're going to do is we're going to multiply the numerator here by x times x plus 4. And the denominator times x times x plus 4. Now remember, when you're doing this, you don't have to say, like in the numerator, you don't have to say x over x times x plus 4 divided by x times x plus 4, right? You've already got that balanced out because you're doing it once for the big fraction. And so don't try to also, within the numerator and denominator, multiply top and bottom. This is good enough. Okay, now what's going to happen when we multiply, since we use the least common denominator has every factor in those inner fraction denominators. So they're going to cancel. By multiplying like we're multiplying, we're going to cancel all the denominators of the inner fractions. Right? In the top here, if I multiply this, the x plus 4s are going to cancel. Right? So I'm just going to get 5x. That's it. Okay, now this is a distributive property here, right? We're going to have to multiply once times the 1 over x plus 4, which will cancel the x plus 4, and once times 2 over x, which will cancel the x. Right, so that'll look like this. When I do the first one, I'm going to get x. Right, the x plus 4s cancel. When I do the second one, I'm going to get plus 2 times x plus 4. And then that could be simplified. That's 5x over x plus 2x plus 8, which is 5x divided by 3x plus 8. Same answer. I mean, I think most of you guys probably want to do the first method. But this is probably like the more used thing. I think in math, generally you would just do what I did on this one here. But again, you don't have to because we've learned another way around it. So here's the first you try. And you could do either one you want. Whatever way you think is easiest for you, then do that. Okay, so I saw a lot of you were doing the first method. The first method. But you weren't finding the LCD. I mean, most of you, to find your common denominator for the numerator, you just multiplied 6 times 3. That's not how you find a least common denominator with numbers. I mean, what's the smallest number that both 6 and 3 divide into? 6. Right? You don't need to go up to 18. 6. What's the smallest number that both 5 and 10 divide into? 10. Right? There's no reason having to make 50. But almost everybody I saw, that's what you were doing. I mean, you could think of it like what we were just doing. The factoring of it would be like this. X over 2 times 3 minus x over 3. So there's the factoring. The LCD then, you include every factor in either denominator. 2 times 3, and there's a 3 there, but we wouldn't repeat it. So 2 times 3 is 6. I mean, really, the same logic applies. Now, you're not wrong if you just want to multiply 6 times 3 and 5 times 10, but there will be some simplifying to do later because of that. Right, so it would have been, I would have just multiplied this one by 2 over 2. Multiplying this one by 2 over 2. And that gives us x over 6 minus 2x over 6 which is negative x over 6. Is that right? Okay. And then in the denominator, we're going to have 2x minus 7 over 10. And then we flip and multiply. Okay, so that will be, see, any common factors? Yeah, in fact, we still have a little bit more simplifying to do, because we could go 2 goes into 6 3 times, it goes into 10 5 times. So there is our answer. Negative 5x divided by 2x minus 7. Okay, what if we did the other? What would be the least common denominator for all 4 of those numbers? 6, 3, 5, and 7/10. About 30. Right? 30 is the smallest number that they all divide evenly into. So we would have gone like this. X over 6 minus x over 3 times 30 divided by x over 5 minus 7 over 10 times 30. Okay, when I multiply 30 times x over 6, the 6 goes into 30 5 times. When I multiply 30 times x over 3, 3 goes into 30 10 times. Okay, divided by 5 into 30 is going to give us 6x. And negative 10 goes into 33, so that's minus 21. So this is negative 5x over, what am I missing? Oh, here I missed the 3. There was this 3 right there. Okay, and so in the denominator I can factor out the 3, and I get 3 times 2x minus 7. Okay, one more and then we're done. So try that one. So I'm going to do this one the second way. What's the LCD for the whole thing? Yeah, for the whole fraction, the LCD is x plus 5 times x minus 3. So I'm going to multiply the numerator times that. And the denominator. Okay, now when I do that in the numerator here, the x plus 5's cancel, and all that's left is 3 times x minus 3. Right. In the denominator, when you multiply this here times the first fraction, the x minus 3's cancel, but you still have 2 times x plus 5. And then when I multiply this times that fraction, the x plus 5's cancel, and I get plus x minus 3. And then that can be simplified. You can leave it at like 3 times x minus 3, or you could say 3x minus 9. It doesn't matter. 2x plus 10 plus x minus 3, which gives us 3x minus 9 times 3x plus 7. That's the answer. Yeah. Can you cancel the 3x's? Yep. Why not? Because they're not exactly. Wow. Kirsten's been listening to me. That's something. Yeah. No, that'd be okay. Yeah, you cannot cancel the 3x's, right? Because those are just terms in an expression. They're not factors of the whole numerator and whole denominator. Okay, so that's it. That's the homework.